Good evening, everyone. Welcome to yet another exciting session of NMIMS Knowledge Series. Our ongoing theme, digital transformation, which started in December, has so far helped our regular participants with insights on the digital transformation as a concept done by Ms. Namrita Mahindru from Mahindra Group of Companies, creating business strategy for digital transformation done by Mr. Sudhanshu Sharma from IBM, and followed by impact of digital transformation in marketing function, which was done by Mr. Girish Singh from Uber for Business. Today, our guest of honor is Mr. Amit Verma, who is Senior Vice President for Digital Transformation in Procurement and Supply Chain for Reliance Industries. He will share insights on driving digital transformation in manufacturing, operations, and supply chain. Mr. Verma comes with 20 years of diverse industry experience, having worked across geographies and industries. He has a successful track record of driving transformation in several functions, especially supply chain. An alumni of IIM Calcutta and a certified Six Sigma black belt, he is a passionate life coach and has helped people rise above their potential. During the session, whatever questions that you may have, please type in the Q&A section at the bottom of your screen, and Mr. Verma shall be taking it up throughout during the session. Wish you for a great learning experience and would like to invite Mr. Verma to take it over.
Hi, good evening to all of you. Thanks, Varun, for inviting me here. It's a pleasure to be here. Hi, I hope you can hear me now. Good evening to all of you. My name is Amit Verma. Varun, thank you so much for that glowing introduction. I'd like to jump straight away, into this presentation and give you a flavor of the digital transformation in manufacturing, operations, and supply chain. I do want to apologize for my voice today. I have a bad throat. I got a cold last morning. But I'll try to do the best I can to make sure that I'm audible to all of you. So just jumping in right away. Hi, just give me a second. We're trying to move this deck ahead. Right. So we're here. I just want to step back a moment and get you into a mindset of manufacturing. And manufacturing has gone through 4 industry disruptions. So we're at Industry 4.0 at this moment, and they really call it 1.2, 3, and 4 is because there have been some disruptive technologies at each point of time to signal that this is a new phase of manufacturing. So industry, for those of you who are not familiar with this term, Industry 1.0 was a lot to do with the introduction of steam power. So moving away from manual and animal labor to steam labor. 2.0 saw that move into assembly lines and electric power. So a lot of, let's say, the cars that were made or carts that were made by hand start getting made as an assembly line. So that was a new shift in productivity. Everything that you see currently in manufacturing organizations is all about 3.0, where you have automated production systems, they have control systems. These control systems help to regulate, they have to form a control loop to make sure your output is right. And now it's Industry 4.0. That's really about the smart factory. It is moving from automated to autonomous systems, IoT, and machine learning. And I'll go a bit into these, in the pages ahead. So what's happened is, through these, if you look at the triggers for this disruption, have been threefold. The first one is industrial IoT, the Internet of Things, and really you have to picture something. You have to take a deep picture into the industrial IoT to understand Why that is so popular and why that's considered disruptive. We've always had machine with sensors, so that's not new. We've always had data coming out from the sensors, some control loop or control system working upon those. So that's not new either. But what you had to do was to keep waiting for the new version of the machine to keep coming out. So for instance, you have, for example, at home, you have a television. That television has a certain amount of functionality and features. And then you have to wait for the next television to come in before you can upgrade those functions and features. But what happens with IoT now is you have an ability to just plug in, a sensor into an existing machine, capture new forms of data, and then use that data to drive, a better control, a better output. And that data can not only just be captured, but also can be transmitted over the internet. And that's why it's things and internet. That's the excitement there. Second is about data. And, these are numbers that you see that are coming out from really industrial operations. So an autonomous vehicle and it's very exciting to talk about autonomous vehicles and how vehicles will drive themselves. But unless you can manage the 4 terabyte of data coming out per day from those machines, which help them configure where they're going, you'd have difficulty in achieving that. So what's happened today is that given the cloud and cloud technologies, and basically 3 laws of data, that's Metcalfe's law, Moore's law, and Gilbert's law. So bandwidth, data processing, and storage. And please look those up, if you like. That's made the cost of data processing really, really low. So what you have in your phones these days, just about 20 to 25 years ago, used to be the processing capacity of that was equivalent to what you fit into a room. So that's shrunk as well, and so has the cost. And the third aspect is basically advanced analytics. So there's been, given that we have a lot of data, the field of data science is involved to both manage the data and also to use new techniques like machine learning, neural networks, to derive different meaning out of the data. And the latest of them is AI and deep learning. So you're probably all aware of machines beating humans at Go or chess. And all of that has been made possible by interpreting huge amounts of data, with these new techniques. So that's the combination of these 3 has really triggered, the industry 4.0. And the technology pillars that we have for this, and this basically, each revolution has technologies supporting it. And these are the technologies for Industry 4.0. And it's a long list. It doesn't end here. Very recently, I attended a workshop on battery technology and how that's going to revolutionize, a lot of production systems as well. So that list keeps increasing. But the main ones are here. To the left, you'll see a lot of the technologies of computing. So that's cloud computing, mobile technologies, cybersecurity, and machine learning. And on the left, you'll see Internet of Things and big data and analytics, the ones we spoke about recently. So big data analytics is possible only because cloud computing is possible, and cloud computing pays for itself only because you can add intelligence. So you're ready to go to Amazon and type over there because there's predictive text helping you make a choice. Otherwise, so these are all of these are very complementary technologies. And what also happens is that if you look at any of these technologies, they're not entirely new or unique, for the last 5-10 years. They've been around for 20-30 years. But it's the convergence of multiple technologies at the same time that has led to, let's say, Industry 4.0, as we call it, has been triggered on. In addition, specifically for supply chain, blockchain is a very, very promising technology. And, the current systems, especially when they go across enterprises, is going to be really revolutionized by that. And we'll get a bit into that as we go ahead. What I'm going to do is just keep looking at questions as well. So that if there's any question for that particular, section, then we'll take that on. So I'm just picking up one very quickly from Shubham. it talks about automated machine as IT features. So you're right. I mean, the amount of software that's there currently in machines is more than the mechanical systems that used to be there before. So there's more software going into cars and industrial machines than mechanical parts. So that's the big change. So in that sense, yes, there is more and more IT into machines, and the number of each company like Siemens, Honeywell, GE, the big ones who make equipment, are hiring a lot more data scientists and software engineers than they used to earlier. The next section, what I'm going to do is just touch upon, and again, give you a bit good context of manufacturing. So we've seen revolutions happen in digital transformation from 1 to 4. But what doesn't change is the following. What doesn't change is what are the business metrics that you're trying to drive. And it's very easy to be lost in technology. And I will give you a flavor of the latest technology that's happening, that's basically in vogue today. But I must emphasize that whatever change you drive in your organizations or as you speak to people who drive change, it starts with the business purpose. So what is the purpose of manufacturing? It is to do two things. One is to make sure that you maximize the yield. So for example, we have chemical plants who are either generating petroleum or gas or diesel out of crude. So we want to maximize that yield. So give us the best price realization, the best GRM. And second is machines and assets that continue working. So most of our equipment is very expensive. We've just gone through a third expansion. In the last 3-4 years, we spent over $10 billion on that. We expect that equipment to run 24/7 for us for the next 10-15 years. And then it'll pay off for itself. So these are the two goals of manufacturing that one would need to focus very sharply on as you start picking which technologies can impact that. And what I'll do is I'll touch upon two cutting-edge concepts that are in vogue at this moment to give you a flavor of how far technology has gone. The first concept is called digital twin. So what this means is, you have a plane, and you can see that picture there. You have a plane which is physically flying. That plane has maybe like 1,000 sensors which have been reading, a lot of data. On the condition, the real-time condition of that plane. And in one of the labs or one of the monitoring units of Boeing or GE, you have a digital twin of that. So this is not a concept plane, this is an actual commercial plane flying around somewhere. So that has a digital twin there. So what used to happen in the past is where you had to give a machine to the pilots and trust the pilots to fly it and react to anything that happens on the ground, that happens in the air, and deal with it. And when the plane lands, people start looking at the issues that you could have, or you go through the inspection. And it's airlines are a very tough standard for machine reliability because it's in the air, right? So you check that when it lands. But now what happens is you're monitoring that continuously. So that's the big change, that's been driven. It's currently very popular in, high reliability of machines like a plane. But I know for a fact in Reliance, we're looking at implementing it in a lot of areas as the cost of implementing that comes down. The second part is on smart maintenance. So there are 3 types of maintenance, and this goes to making sure that your asset is reliable and ready. It's always delivering, especially the process plant, which works 24/7. That's what you want. So the first type of maintenance is reactive maintenance. So you go to the machine is shut down. It has tons of data. The data is extracted from that machine or the SCADA historian, and you pick it up and you figure out what's gone wrong with the machine. So some part of it is to physical checking, but a lot of it is to data checking as well. And you fix it. Preventive maintenance is when there are certain schedule of maintenance that are put together based upon the laboratory life of a machine. So there's a turbine blade which is meant to perform X number of cycles for, let's say, 18 months. So after 18 months or that number of cycles, you should replace it, because if the turbine is in operation and that gets damaged, then the damage to the turbine is very high. So you've got to change that part before. But I'll take you to what's coming on now, and a very, very interesting concept is predictive and prescriptive maintenance. So two concepts I'll leave with you over here. So one, you have a lot of data that's already there in process industry. For example, my company, we have absolutely no shortage of data. Data has always been there. We've been able to take that data out and now run machine learning programs on that, in collaboration with a lot of the OEMs, to start predicting, saying, given the condition of this valve or given the parameters of temperature and pressure, we predict that something isn't right, and check and change this part before it gets bad. Right. Recently, I was in a meeting with one of our OEMs, and they were sharing this example over here. You see on the right of the turbine or the turbine blade. So what they've done is, and this is it's completely mind blowing as to what you can do with smart maintenance. So as I was sharing earlier, turbine blades are very high part of the expense of a turbine, and they have to be changed every 18 months, and that's the biggest maintenance cost for them. And what they've managed to do is to have a ceramic strain gauge put on the blade of the turbine, and there's a camera which continuously focuses on the place where that strain gauge is, and measures the change in the gauge to understand whether some corrosion has taken place or some stresses and strains have taken place to damage the blade, and then that's change versus the fixed 18 months. So it's extraordinary. I mean, some of you are, engineers are familiar with this concept. Most damage occurs because of stress and strains for different reasons, and if that can be read as it happens, then you would end up saving 50% of the cost, or delaying the change of the blade by 6-8 months, which is a 20-30% cost change as well. That's sort of cutting edge, it's as cutting edge as it's getting in industry today. And the promise of that is that today it's in turbine blades, and tomorrow it will be in every machine that you have. So tomorrow your washing machine will prompt you and tell you, I'm going to have a failure and it's getting fixed. And you won't have to pay the expensive service and maintenance that you do at home. I'm also leaving you with this chart of predictive maintenance, of showing what are the technologies which are, so this is called as the hype curve, where everything starts, on this part of the cycle, and in the left part of the cycle, where you think every problem can be solved with that. It goes through the peak of inflated expectations, and then it comes down to what it can achieve. Virtual reality is one which is really helping, engineers who fix machines, really see an augmented machine. So basically, when you go into the machine, you're not only seeing the machine, there's data on top of you telling you what the condition of that part is, and what that part is, and what maintenance is prescribed for that. Again, I'm going to stop for questions very quickly and see if there's any new questions. Question, can I speak in Hindi? No, I can't speak in Hindi. I'm assuming this is meant to be in English, but I'll try to use a few Hindi words in case there's some concept that's difficult. Second, how can we reduce the cost of chips and other devices? So that's taking care of itself. So that's Moore's law, that the number of transistors on every chip doubles every 18 months. So double the number of transistors means half the amount of cost. So that's what's happening. So what also happens is you don't see actual cost going down, because the features that you want on you, when you start the mobile phone, you want to just call, and now video is the biggest part. You want sensors to detect our location, where we're walking. So that the need for data processing keeps increasing. So while you don't see an absolute change of cost, the cost of chips are really going down. Blockchain I will come to in the future, and also cognitive computing. Cognitive computing we touched upon a little bit over here. Moving ahead, so the other aspect of manufacturing operations is the supply chain. So you've got a factory is working to maximize output and it's conditioned for that. And what you also have is, machines that are working, and now what you need is raw material and an MRO to come in, into the factory, and finished goods, to leave the factory. So that's the supply chain part of it. And again, I will re-stress on sort of the business parameters of supply chain. So A is logistics. What you want to do is be absolutely efficient with them and have them on time. Second is stores. That's your major working capital that's blocked there. So you've seen a lot of concepts of, just in time, as a concept which has been around for some time. And third is in terms of forecasting. So you're moving to a pull method. So basically what you're not producing based upon what you can produce, but you're producing what a customer wants to buy. And hence, your inventory at the finished goods part is also very low. So it's very, again, important to remember, what is the lever that you're working upon and which technology helps that. I'm going to go in the next 3-4 slides to talk about, again, cutting edge concepts in these areas. There's a lot happening, and this is a very wide area that I'm covering in today's webinar. So what I'm trying to do is to just share a few inputs that open your mind to reading more. So this is by no means exhaustive. So moving into logistics, the first part is the logistics control tower. For too long, we've had disparate data systems, information. So if you're trying to import anything today, and given that a lot of supply chains are global, there's more and more both input material and spares coming in from overseas. It really goes through at least 7 to 8 hands before it reaches you. Starts from the supplier, and maybe the suppliers send it to an aggregator who aggregates it, who's a trader who's really supplying to you, or someone who's aggregating across a couple of suppliers and assembling it together and supplying it to you. And then that person puts it to a freight forwarding agent, let's say in Germany. The freight forwarding agent will give it to a shipper. The shipper will bring it to one of our ports here, to the port authority. And what's happening at each stage is that there's a lot of data, a lot of information being gathered. That information is all there. But unfortunately, what's happening is it's either shared by emails or paper, and it's a very inefficient system. And a lot of people have tried to grapple with this. But now with IoT and mobile, what a lot of companies have managed to do is to have a control tower. So exactly how you see a plane starting from an airport in, let's say, Delhi and flying down to Mumbai, and you can track it all through part and guide it if whatever goes wrong with it. It's the same with the shipment. So you can track the shipment from a barcode when it starts from that supplier. And a lot of data is added to the barcode. So the name of the CFA, the name of the shipper, and so on and so forth. And you can actually figure out that now my cargo is not just 5 days away, but is on a ship that is now traveling from Dubai to, let's say, Kandla, and coming here. And you can track it all the way. So the visibility of this helps you manage your inventory much better. And again, I'm stressing the point that this information was always there. It was just cumbersome to pick that information from paper, put it into a system, that system being common for all of these, companies, and getting it into a manageable format. One of the, on the same line, one of the very ambitious programs of the government of India, Digital India, is also an e-way card. So basically, so you have to have an e-way bill every time you move goods within India. But now you would sometime soon, you would also have that information being available electronically in a card. So as you go along the route, it can be scanned, it can be, picked up electronically as well in the system. So if that happens, and that will happen in the next couple of months, if not years, then that would be a revolutionary in domestic shipping as well, where the government has helped build the common system to capture this data information, and that's the most difficult part in cross-enterprise, goods movement. The second concept is a little counterintuitive. So while a lot of people are working, and this is how it happens in revolutions, right? You're banking on one technology and you're taking that further. Whereas there's blockchain technology now trying to disrupt even, let's say the system of rules and standards has been put together to capture information. So what's blockchain? Someone asked me that question. So blockchain is basically, it's a ledger. For those who are familiar with accounting, ledger is a book where different records are added. Records are, I bought something, I sold something, and that sort of keeps sort of like a data of all of that. And so what blockchain does is blockchain keeps basically a record of everything that whoever is doing with that transaction. So let's say the transaction is what we saw in the earlier page, a good moving from a supplier to Reliance, Jamnagar facility. There are 10 people involved. So as the 10 people carry out a transaction, that transaction is very securely added, to this blockchain. The blockchain, let's say it's an import blockchain. And that takes out the need for paper to flow. So two aspects, right? Why do we have paper? Paper is, you need to trust the person putting that information on the blockchain, right? So blockchain technology allows you to verify, the person putting in. And second is, once it's put in, it cannot be amended by anybody else. And if that person who's put in wants to amend it, then the amended record is kept, right? So you really have a absolutely non-modifiable chain of information put in by different people in whatever format they want. So the format is pretty flexible with this. So this blockchain started off with really with Bitcoin, but this application where you deal with transactions, across companies, blockchain is going to really revolutionize it. So if you think of, SAP, and SAP works very well for an enterprise, it's exactly what blockchain is going to do across enterprises. So this has been attempted. I think, I saw that B2B boom where, a lot of this happened about, 15 years ago, 2003-ish, when we tried B2B marketplaces and this was tried. It failed. We couldn't move beyond EDI, electronic data exchange. But that's very expensive and works only when huge amounts of transactions are between two entities, only two entities. So this will really revolutionize it. I can go a bit more into detail if you have time at the end of the session and if you have any questions around it. The second part is 3D printing. 3D printing is, not any science fiction concept. If you're in Bangalore and if you want to change, you want to, your tooth, if you need a new crown, chances are that, your dentist will take a quick x-ray of that, send it to a 3D printing lab, will make a mold, and the mold will come back to your dentist, and the dentist will actually create the crown with whatever material is using, ceramic or whatever material is using to create the crown for you. In Zaveri Bazaar in Bombay, a lot of the jewelry designing is happening with 3D printing. So it's not as easy as you think. It's happening today, happening everywhere. And the concept of 3D printing is you can have all the blockchains of the world. What if there is no movement of material, right? What if instead of sending a spare part, from Germany to Jamnagar, someone sends a capsule which has the information to print a spare part in one of the printers in the facility we have in our premises. So as you can see, it's just taking away, you can see the 4 layers of sort of from conventional manufacturing to distributed 3D printing to basically ending up with 3D. You can go and print a book from, Kindle anywhere. And you can buy a book from Kindle anytime. That's the 2D printing part, and that's what's going to happen with 3D printing as well. And the other revolutionary part is, why make a new part when you can repair an old part which much lesser cost So again, those of you who are engineers here will recognize this is a gear which has broken teeth, and that's what usually happens. The whole part doesn't break. It's only parts of the part that gets worn out, so that it's teeth of the gear, or let's say if it's a shaft, then a shaft is worn out in certain sections. And 3D printing is a really exciting part, and in Reliance we're doing a lot of trials on seeing how is it possible, what's possible, what's not possible, what metals is it possible with, what standards does it adhere to, and can we start dealing with it. But this is a part which has been fully printed gear, and that's been used in production in one of the OEMs that we're discussing this with. So when you think of technology, also think of it multi-layered. While you're investing in a control tower and upgrading your sort of competencies to the next level, there's somebody else investing in 3D printing, which could make a lot of this sort of redundant. But all of them will exist for the next 10, 15 years. There's direct material like crude and chemicals, which can't be 3D printed. Those will travel. But there's a lot of spare parts, MRO, machinery parts, tools, which will start getting 3D printed. So MRO is the most likely part. When you think of insurance spares, so insurance spares insurance spare is a spare which is needed at a very quick, with let's say if you have a break of a important shaft in one of your equipment, you need or a rotor, you need another rotor kept, and that rotor will keep lying with you for like 5-6 years till it's really needed, right? But you need it at hand because you want to wait for 6 months for a new rotor to be shipped. So you could see a drastic reduction of insurance spares with 3D printing, and that releases so much of working capital, for companies where all of this capital is to be locked in, and that's taken as cost of business. So that's how some of these technologies are really disruptive. In this section, I'm just going to see if there are any questions, and then take those questions, and then go ahead. So talking about chips technology, graphene. Yes, graphene is, as I said, the list of technologies. So Kalyan, I'm answering your question. So the list of technology is not exhaustive there, and we're going to have new material, new forms, keep getting added to that list to do that. Manoj, cost benefit analysis of technology. So I would answer this in two parts, right? So every time you're looking at a technology, assume the cost is going to go down. So if your cost benefit analysis says that by investing in some technology, if I invest 100 in the technology, I can only take out 110 in terms of value, go ahead and do that. Go ahead and do that, because that 100 will become 80, 70, 60. But the knowledge of extracting value from, let's say, that data or that technology will be invaluable. So you would have gained that. So your cost benefit will only increase, as the years goes ahead with the same technology. What's important is to figure out how you deploy the technology. So you have to deploy the technology in a way that can be, like you have a phone today. You buy a new phone, you don't have to put in everything else back into it, right? So it's kind of replaceable. So you buy technology either on a time basis or on a basis of replaceability. So you build components around it so it can be plugged in and plugged out. It's easier said than done, but that's how you truly maximize the output. I'm just scrolling ahead to see. So optimal resolution of data. So KPIP asking a question saying how much of data is good, right? That's how I'm reading your question. The answer today so it's a tough question, but the approach that industry is adopting today is just store all the data, because we don't know what is the use of the data tomorrow with tomorrow's technology. But again, store data which is with a certain time horizon. So if I have some, let's say, temperature and pressure data, every second of temperature and pressure may not be useful. Maybe there's a 5 minute time span of that data is more useful for me, right? But I've seen a change in the last 10 years where people are saying, I don't know what to do with the data, but I'm more and more confident that I'll use the data tomorrow or something else to do that. Again, I'm scrolling through the questions. Vishwaroop, I'll come to your question, in a bit ahead. And so Venkatesh, let me answer your question. Before this role of the digital disruption, I used to buy all the indirect procurement for Reliance, and that's huge, about like $300-400 million worth. But we could never get, let's say, and I'm giving you a very simple example, so it's very easy to understand, is we could never get the rates that we get for a cab like Ola and Uber does. And the reason was that technology was being used to track quantity. So, the cost is basically unit price into quantity. So they were doing a much better job for using that data of quantity, saying where is the cab located, what is the route it's taken, how many kilometers has it driven, what's the utilization of that cab, go ahead. So when you start looking at that problem very differently, right, in terms of saying that every minute an asset is not being used is actually being wasted, then, you can really change, the kind of cost equation. The cost is like, the savings are 2x, 3x, not 5%, 10%. And as long as it's linked to one of the business impact areas, which I agree, the customer satisfaction models will be high. So I hope that answers your question. I'm going to come back to the presentation again and go through the remaining parts. And we'll come back again, I promise, if you have more time for questions. But thank you for your questions. Keep coming, keep them, coming ahead. So this last part of this is, you have you basically have a lot of people in, in a manufacturing organization, and especially if you have an automotive. So process plants have lesser number of people, but automotive have a lot of people. And what we're trying to do is looking at, again, there are two aspects very important to people in your organization. One is productivity. Are they delivering what they can potentially deliver? And productivity is not just spending more time at work. So that's a very old notion of productivity. And the second is, do you have a safe environment? And we're going to touch upon 3-4 things that my team is currently working on, to deliver that. So A is part of connected worker. So we have, like 4 themes that we're driving to sort of link up all of our mobile resources. So you understand, if there's a plant, there are assets which are installed. So these have tons and tons of data coming from them. They have DCS controlling them. They have systems controlling them. And then you have assets which are mobile. So which are dumpers, cranes, people, material. And these are the ones that we're focusing on to make them connected. So I give you a very quick example of each one of them. In terms of connected worker, it is, usually our experience is that of a full workday of, let's say, 8 to 10 hours is only 40% at best, or 50% at best of useful work obtained. And that's got nothing to do with the willingness of that person to work. It's got to do with logistical issues. It's got to do with, some of these being present. For example, a person, I can only give this webinar if technology is working, so it's streaming, this machine is working, and there's someone to listen to it, right? So unless all of that happens, I can be ready to give webinars, but that doesn't happen. So the same way with workers as well. So as you track what a worker is doing, you try to identify more and more granularly what are the bottlenecks in the process that prevents that person from moving to 40 to 50%, 50 to 60% of productivity. And then removing those, finding the root cause of those bottlenecks and eliminating that. It's the same with connected machines. So today we have, cranes where we can measure everything. We can measure the amount of fuel that's put in, the amount of fuel that's consumed, where that crane is exactly, whether the safe load indicator of that crane is on, what's the data it's giving you, Is the operator authentic? Is he certified to drive it? Also, if what's the load that crane is carrying at this moment? So you're able to measure all of that sitting in a room. Same with connected material. There are some materials are very specific. Today as a customer, you're aware that each of your packages are delivered home by any of these e-commerce companies are barcoded. Shockingly, that's not yet in inventory. So we have tons of inventory, in our warehouses, but we still track them by putting them in fancy cupboards that we call as, racks, and pulling them out from there. But imagine a scenario where each one of them has an RFID tag, or at least the most important ones of them have an RFID tag. And you'd never miss the material, find it very quickly, and be able to use it. So again, some of you would see this. We've been in the industry for about 3-4 years. I want to take you back to the process of Lean and Six Sigma. So this is exactly what we did, right? So when we had a problem in some machine, some process line, we did a time motion study, right? So to go and sit with the man who was working and try to track what he's doing, looked at the machine. So we should pick up samples of data, just to put that back into our Excel sheet and try to figure out the root cause. And that worked pretty much. But just imagine that time motion study, not just gathered for a sample, but gathered for the whole population. And gathered not just, so there's no bias. You're not biasing the worker by observing him, but it's just there on him. Like, you have a walking tracker or a Fitbit or an iWatch or something on you. You're not noticing it after some time. It just becomes part of you. So you're not biasing the sample, you're actually measuring all of that. And once you have that, comes the last part, which is the connected process. So now you're able to combine all of these three and truly take up productive value. And the experts say that there is, maybe a 50%, so more than 40 to 60% is really possible with, a lot of these being connected. So the concepts we talk about at this moment is digital refinery, with a whole refinery. So it's not a digital twin of one equipment or a plane, but it's a digital refinery or a digital airport, where you can see everything that's happening, and the data has been generated. A lot of AI and machine learning is working on the back end to give you the right alerts, because a human cannot absorb so much of data. So that's where machine learning and AI help us to pick up that data and use it in, give it to us in a more usable format. The last one, and again, then I'll come back totally to questions, is, we started off with talking about the excitement of technology and Industry 4.0 and what technologies are triggering it. We came back and spoke about the fact that technology isn't the driver, it's still the business cause. The business cause hasn't changed at all. It's still the same. The reason why we're using technology stays the same. It's reducing cost, improving revenue, improving profits. And the third part is the cultural aspect of it. It's saying that, why are some companies are successful in this in this disruptive atmosphere and some are not. And it goes back to looking at the culture of the company in doing that. And it's very important, I think, for all of you as students and to also sort of think about this. It's not knowledge of technology, but also how you, what are your behaviors that will drive you to be successful in this area. And just using framework of Spencer Stuart and trying to stress upon that. So if you look at this framework, it talks about independence and interdependence. We talk about stability and flexibility. And you'll recognize some patterns here, right? So if you look at startups, which have been very successful, doesn't matter whether it's B2B or B2C, what have they done very successful? So the first part's about learning. On top of that, you see a lot of learning coming in. I was in school about 20 years ago, so 99, so I graduated from my MBA. Engineering was before that. I'm sure everything's outdated. Some concepts are not of business, but a lot of the skills are getting outdated, and I need to keep continuously adding to my learning to do that. I've recently gone through a micro masters from all these institutes figure that out. I'm currently doing a course in machine learning as well as we speak. So does your company and you encourage learning? Because when you're talking about disruptive change, you're saying companies of the past which don't change will not be successful in the future. But it's also about people. So people who were successful in the past, unless they adopt a lot of new learning and new thinking, will not be successful in the future. It also talks about this quadrant being a little bit more heavy, the top one, the flexibility one, what purpose, what caring and enjoyment. It's so easy to get lost in, just in technology or in learning. So it's moved from, let's say, safety and order to more of learning and enjoyment. That's the change we're seeing. What is also moved towards is a lot of interdependence versus just independence. So, and it's a shift, right? From through the ages, a person is doing lesser and lesser for himself in terms of meeting his needs, but relying on everybody else to meet that. And that we're seeing that trend continue as well, where you would continue to become more and more interdependent on the workplace to deliver results, because it's getting more complex, it's getting more deep. And unless we, so a lot of focus now in organizations is on cross-functional work. So it's not just project work is cross-functional, but companies are looking cross-functional. So if you're looking at a supply chain, the IT guy is not some person who's in an IT department, but is part of the supply chain team, because you're building, let's say, tools and features and alerts on the go. You can't afford to, leave it as a separate project. So we're building capability as you run your operations. So I'm going to, again, as I said, my focus of this webinar is more on opening your minds to thoughts. And if that encourages you to read and interact with me and, stay connected with me as well, then, I think it's a process of change where 1 hour isn't enough to understand digital disruption in manufacturing, but 1 hour could open your eyes to what to look into in digital in manufacturing and supply chain. So I'm going to end with, this formal presentation, come to just the Q&A part with this quote. One, happy Valentine's Day. Thank you so much. About 300 of you, logged in at this moment. So thank you for logging in. I'm sure your loved ones are waiting for you to get back to them and celebrate this day. And sort of a joke that with Dilbert, where, it all starts with having the right data and the right metrics. Otherwise, it doesn't matter whether the data is accurate or not, or it doesn't matter whether the algorithm is right or not. So just leaving you with that thought. Now I'm going to go into the Q&A and just, scroll through them and try to answer some of them. If I don't then answer these questions, then feel free to connect with me on LinkedIn. Again, I won't promise I'll answer those questions there, but it's good for you to stay connected. And one form of learning is micro learning through social media. So I understand this webinar is being broadcasted on Facebook Live as well. And I'm sure a lot of other people have great videos too. So learning today is not restricted to formal webinars, but do get onto social media, do stay connected, do keep absorbing. Okay, so questions. And again, I'm going to scroll through and walk through. 3D printing machine ROI. So again, 3D printing is very common in the polymer parts. So to create a mold, basically. So I explained that, either in jewelry design or prototyping of equipment or crowns, that's commercial now. In metal, it's getting there. And, you see a lot of that about that. Someone's asking me a question on 4D printing. I'm not aware of this 4D printing. So something I'm noting down and I'm going to read about it. Do that. So question by M5PC, my PC. So it's a wonderful question. So the question is, data game is the new business model, and companies like Google, Facebook will be the kings, right? So I'll just explain this in the industrial context so you understand that. So one of the goals of every company in the industrial area is to saying, what is the digital revenue I'm going to earn in the future? And what does that mean, right? So digital revenue means that, let's say there's a company which sells a turbine today. So it is billing you the cost of the R&D of the turbine, the cost of manufacture. And going ahead, it bills you the cost of spares, it bills you the cost of services it does for that machine. Now what they're trying to do is to sell you a package on top of that, which is saying, by the way, you can use the software to also do predictive maintenance of that. You can use the software to also optimize it. So that's the digital part business that's coming out. So it will either be the OEMs will be able to understand their machines their best and sell this digital revenue, or like it happened with Uber, the car companies were late in doing it and someone else did it. So Uber has now converted every car to an Uber car because the data from that car is being used to drive a business value. So absolutely right. So a lot of things, what's going to happen is they're going to move from an equipment to a service. So you no longer want the car, you want a car right? So you no longer want a turbine. What you want is energy at this rate to be available to you. And only, let's say, electricity companies could do that. But a lot of companies will start doing that, and that started as well. It's kicking off everywhere where the asset part of it is very light, and hence the service is provided through data. Data leakage, theft, impact. Manoj, your question. So absolutely crucial. If some of you love to follow politics and, but I'm just giving a hand when we're running out of time. So some of you like politics and you read about the Iran case where, they managed to shut down one of the nuclear facilities. So what's rumored is there was a part in which somebody inserted a PCB which had that virus, which basically reached the reactor. So it was normal machinery that came in. And that caused the downfall of that. So that virus caused damage to that reactor. So that's a very real scenario in industrial part of it. So it's either someone coming into your company and damaging data, or someone taking data out, and that's an impact. So both are the same risk. And we're finding that continuously. And insurance companies today, when they insure a facility or a company, they're focusing a lot on data security, which was not the case, a couple of years earlier. Some more questions. So we're talking about, Sudhanshu Sharma is talking about 3D printing for mass production. Again, one of my favorite topics. But, so if you, I'm assuming a lot of you understand 3D printing, but for those who don't, it's like 2D printing, right? So when you see a printer printing, it doesn't write like an alphabet moves, right? It just moves back and forth and keeps putting dots. And the sentence and the words emerge. It's the same with 3D printing. So if you have a complex part, like this, then it's just printing layer by layer. And what's happening is that currently when you manufacture this bottle, you're manufacturing it, which is limited by conventional manufacturing. So you cannot print you cannot manufacture certain types of material with, or shapes, actually geometric shapes, based on conventional manufacturing. So wherever you're able to manufacture an unusual geometric shape, that's where 3D printing is coming into mass production. So a lot of aviation, for example, space work that is there. So there's a big payoff between cost and weight. So you can really reduce the weight of a part, then the payoff is very large to do that. So they use unconventional geometric shapes to do that. And that's where 3D printing is almost getting into mass production. So mass production is still about not into millions of parts, but thousands of parts. But that's completely there. Karthik Desai. So his question is all about if the automation in the industry is about then the number of people required for that particular job or fewer, and hence how will we have jobs? So two answers to this. jobs with the old skills will become fewer and fewer, and unless we don't upgrade ourselves with new skills, we will not be able to find a job. So that's the reality. That's not going to change. So I would be lying if I said that jobs will be plentiful. However, jobs of new skills, new industries, 3D printing wasn't there. Managing of 3D modeling wasn't there before, right? Blockchain skills weren't there. So there'll be a lot of jobs, for people, for these new skill sets. Having said that, these new skills are tough as well. So it'll be a social challenge for us to, get everybody to learn, let's say, these tough, new, complex skill sets, because, the basic things are being done by machines at this moment. So then it'll become tougher and tougher to have a great value-adding job. But the promise is also there that if productivity becomes 2x and 3x, then can we, and we're getting at the news a lot, but that's, the biggest question that I've been debated in digital is also the ethical part, saying, can we come to a minimum wage? So what is the tax paid by a robot being used in a factory, right? Because so each person, so I pay 30% of tax, 30% of my income goes to the government as tax, but a robot pays 0 at this moment. So can we start creating a mechanism where higher productivity is translated to, let's say, covering the minimum sort of health, food, living for people? And we've not been great with this as a society, but I think that's our challenge for us to become better at that. Let me go ahead and look at some other questions. So there's a person called NMIMS asking a question, is database management a part of management of supply chain? So I'm just reading the question a little differently. I'm saying the question I'm taking from here is that data is becoming more and more important part of supply chain, and is managing data important? Absolutely important. So today, from, let's say, a ship or a truck, you're going to get not one alert saying, I have started and I'm going to reach in 3 days, but you're going to get some feed saying where that truck is every 5 minutes, every 10 minutes. How do you manage that part of data? So that's so supply chain teams are going to have a lot of embedded skills of data management, and that's 2 skills. One is data engineers, who basically make sure that the data is collected and stored in the right format, and that's basically people who are experts in cloud. And second is data scientists, who are able to derive some useful meaning from that data. So data is useless unless it's interpreted in the right fashion, and so they would pick up that data and draw insights from it. And I think there's another related question from Mahendra, also talking about data mining. So I'll just touch upon that. So data mining means that, like, you go into a mine and ore, and you find, out of all the rock, you are able to find the ore, whatever you're mining for. The same with data mining. So you're able to find in the whole data stream either the answer you're looking for or the pattern you're looking for, pattern more precisely. So that's data mining in a very brief part. So how do you process that data to take out the right insight? The insight could be an alert on a shipment getting late in supply chain, an alert that there's a rally in Bombay, so whatever was projected to reach here today won't, and will reach here tomorrow. Right. So those are the kind of alerts where you're picking up, it's a social media data of a rally, combining it with actual traffic on the ground and relating, saying, aha, I know why that traffic's happening in this area, and that's going to be the impact of my supply chain. That's that. Again, about blockchain, have Indian companies thought about blockchain in supply chain? Yes, absolutely. Blockchain adoption happens in ecosystems. So it's not just one company which has to pick that up. It has to be a company which allies across the ecosystem. So if you're looking at exports, it's the supplier, it's the customer, it's the freight forwarder, it's the customs officials, it's the banks. All of them have to come together on the blockchain. And that we did our first transaction in Reliance very recently on a shipment. But I've also seen very interesting use cases. A startup that I keep interacting with, they're building a blockchain on warranty. Right. So how can you do warranty of consumer items to understand? So for example, what you're going to say is that there's a phone on the this is the computer. On the computer, the screen has failed. But by the way, this screen came from this shipment from that particular sub-supplier, because you have 3 sub-suppliers of this particular screen. And how do you have more back-and-back arrangements going back from the total end customer to the first level part? I mean, it's becoming, for example, in medicine, it's becoming more, the origins of that. So if someone is saying, I bottled water in a Himalayan fountain, is it really the Himalayan fountain where this was bottled? Okay. Someone has said you can't find Amit Verma 09. I look for Amit Verma Reliance then on LinkedIn and maybe you'll be able to find it. But, it's usually the last, the ID, the handle that I have on Amit Verma is Amit Verma 09. So if you go to the search button and type Amit Verma Reliance, you'll probably find that. Upgrading skills. This is extremely important. So today, there's a lot of thinking in the industry that skills matter, not the degree through which you earn the skills. So whether we're looking at, distance and online education programs, and NIMS is one of them, one, do get a degree. That's really important. There are enough people who go through the newspapers and learn the top 50 buzzwords of blockchain, 3D printing, and be able to bounce them. So you've got to be able to show something about them. But my suggestion would be to build skills in the area where you're working, or to start working in the area where you're building skills. So if you are in supply chain today and you're attracted to data and data management, start picking data management courses, or let's say, machine learning courses, and start applying it to the work you're doing today. So the combination of experience with that data will give you a lot of jobs. And trust me, for a lot of these digital skills, these are hot skills today in the market. There's a shortage of these skills. But equally, there are enough number of people who are saying they know something, but they don't know something. That's usually been a problem. So complement educational programs, not just by your degree, but by your experience that you do that. I'm going to end this with one last example of blockchain in SCM. So in fact, 2 examples, one very revolutionary. So Elon Musk in Tesla wants to make sure that if a door of his car is damaged in an accident, then he can trace the aluminum in that door, right from the door to the car, to the date it was manufactured, down to the ore where it is coming from. So they can start understanding, what causes some failures and deaths versus others. So you're actually going down to, the whole, you're trying to trace that material from the finished product to the ore. So that's one. Second, Maersk is doing a very, very interesting, example in blockchain where they're trying to connect the whole export industry. So do read that up. It's a case study by IBM and Maersk, available very easily on the internet. Very interesting fun fact of Maersk as well, where someone talks about learning and so on. So Maersk has realized that, it wants to be the Uber of shipping, and has recently gotten the head of its company as a person coming in completely from a software background. So it's easier. So what's going to happen? What's going to happen a lot is you're going to see people of software with these digital skills coming into very traditional industries to sort of complement the domain expertise of the traditional industries, and then create these blockbuster ideas to drive that. Okay, so I think that's fine. Then I'm going to pause here and hand it back to Varun.
That was a really exciting session with Mr. Verma. I'm sure you all had a great learning experience. Please feel free to write to us at ngiasc@nmims.com.edu with your questions, with your feedback. Do visit our website distance.nmims.edu. And in case you have any questions, any suggestions for us for upcoming webinars, do let us know. Thanks a lot for joining us. Have a good day.